My name is Mahnoor Asif and I am from BS Physics Department. My ID is 005. My presentation topic is nanophotonics. For the question arises, what is nanophotonics? And what is nanophotonics? Nanophotonics is the study of the behavior of light on the nanometer scale and of the interaction of nanometer scale objects with light. And then I am telling about the introduction of nanophotonics. The term nanophotonics is just like the term optics. In optics, we studied about the lenses, usually concern ultraviolet, visible, and near infrared light, free space, and wavelength about 300 to 1200 nanometers. And then I am telling about the principles of nanophotonics. Normal optical components like lenses and microscopes cannot focus light to nanometer scale, but it is possible to squeeze light in a nanometer scale using other techniques like there are four other principles and techniques super surface plasmons, and the second one is metal optics, and the third one is near field optics, and the last one is metal materials. And then we discussed one by one. The first technique of the nano photonics is surface plasmons. Surface plasmon waves possesses the ability to confine optical energy to sub-wavelength volumes. The attractive features have encouraged and lead to research development and new device opportunity in numerous areas of science, including new photonics. And then I'm telling about the second technique of nanophotonics. Metals are an effective way to confine light to fall below the wavelength. For a similar reason, visible light can be confined to the nanoscale and nanoscale via nano-sized metal structure such as nano-sized structure, tips, gaps, etc. The effect is fundamentally based on the fact that the permittivity of the metal is very high. And then I'm telling about the third technique of nano photonics. The third one is near field optics. The highest frequency correspond to the very fine features and the shape edges when light is emitted by such an object. The light with very high spectral frequency forms an ancient wave which only exist in the near field and disappear in the far field. Nanophotonics is primarily concerned with the near field evanescent waves. Yes, the question arises, is nanophotonics is present in nature? Yes, nanophotonics is present in nature in many things. Here there are some. Nanophotonics is present in butterfly wings. Butterfly wings are naturally photonic crystal assembly of CGS nanoparticles. Nanophotonics are also present in the leaf of trees, plants, etc. And also nanophotonics is also present in the peacock feathers, and nanophotonics is also present in the photoreceptor rhizospine. And nanophotonics is also accept these. Nanophotonics is also present in many various things. Advantage, and then I'm talking about the advantages of nanophotonics. Advantages, some of the advantages of nanophotonics is are the first one is bring access to further integration, and the second one is lower noise. The third one advantages of nanophotonics is will dissipate less energy, and the fourth one advantages of the nanophotonics is will require low input signal, and the fifth And the loss advantages of the nanophotonics will probably rely on self-assembly. And I'm telling about the applications of nanophotonics. Except here there are some applications of nanophotonics. Except these, there are so many applications of nanophotonics. Nanophotonics in solar cells. Solar cells, nowadays we use solar cells in our homes, in the form of solar planners, and we get electricity with these solar planners, and this is very useful for us. Nanophotonics will efficient solar cells to make cheaper than the conventional one. Microscopy. The goal of nanophotonics super lenses, which would use metamaterials or other technique to create images and more accurate than the difficult limit. With the help of microscopy, we saw all very small things, with very accurate image. Um, in the microscopy we saw accurate image. And then we are I'm telling about the nanophotonics biosensor. This is also the application of the nanophotonics biosensors. The detection biosensors are also present in the form of chips like these, the detection of traces. And also this is the example of ultraviolet traces. The detection of traces and ultraviolet traces of toxic and harmful compounds in air by using network of small sensors like MAMS. The abbreviation of MAMS are micro electromechanical system, are labs on chip devices. Chip devices like this. In this picture we are given the chip device. In medicine and biology, nanophotonics are also used in medicines and biology. In medicines and biology, DNA assisted assembly of metal nanophotonics. This is a picture of the DNA. Thank you, that's all from my side.